of IEEE Consumer Technology Society. And it is my pleasure today to welcome you to the first webinar of the series Technical Talks of CTSoc. This series of talks originated within the context of the technical activities area. This area of the society is responsible for managing and covering the technical aspects in the field of interest of IEEE Consumer Technology Society. And there's a website dedicated to this area. And the activities are promoted through mainly the technical committees and the Future Directions Committee. I think that many of you are already aware, are members of the technical committees. There are 15 technical committees which have been established starting January 2021. As you can see from the names, they cover the areas, all the areas of interest of the society. The technical activities area is organized in these technical committees, which are reporting to the technical committees board, and the board is reporting to the VP of Technical Activities, and also the Future Directions Committee is reporting to the VP of Technical Activities. As you can see, the board is a supervisory body in which are represented the CTSoc president, the VP of conferences, the VP of publication, the VP of industry and standard activities. So basically, you see that the technical activities are covering all the areas of the society. And within the board are represented the officers of the 15 technical committees. Each technical committee has a chair, as a vice chair, and as a secretary. Each technical committee has a website in which basically there is a description of the mission, the objectives. There are the officers and members with their names, with their affiliations, their countries. Here you have the officers of the 15 technical committees. The officers are elected. These are the names for the second term, 2022-2023. And as you can see, there are a number of names which are in gray. These are the names which are new from this election. So it's easy to see that there is a change in the volunteers serving the society, meaning that there are experts which are still contributing to the society, and newcomers which bring new blood to the society and its technical committees. As members of the technical committees, you probably joined them. If you are members, you probably joined when the committees were established, or in a continuous process of enlargement of this family of members. There's a membership application form which is received by the TC officer, which periodically evaluates the new application and notify the applicants about the outcome of the evaluation. You don't need to be a member of CTSoc or IEEE to be a members of the technical committees. So if you are not a member and you joined it today because you got information about this webinar from your colleagues, please consider joining. I will show you the link for to the application form at the end of this presentation. We are now approximately 850, 900 members. Some of them were invited at the beginning based on the service they provided to CTSoc conferences. Some other joined later because we advertise and spread the word also not just to authors of conference paper, of colleagues who served in conferences, but also to authors of journal papers in our publications. And we also reached the network of contacts of our officers and members and through the channels of CTSoc. As you can see, all the committees are well participated. The role of the technical committees, as many of you know already, is to support CTSoc activities in all the areas: conferences, publications, standards, education, and history. Their goal is to investigate, evaluate, and promulgate and foster current and emerging technologies and applications of interest to CTSoc. The goal is to create additional technical committees for technologies of interest to CTSoc and conduct periodic and special technical meetings. New initiative, new committees can be created in collaborations with other CTSoc technical committees, with other technical committees of IEEE societies and council and other IEEE organizational units, and also define new areas of technology focus and encourage the formation of new initiatives through CTSoc FDC. Just to make an example, regarding conferences, the technical committees are responsible for reviewing and approving the call for papers of conferences, to support conferences by contributing papers and providing reviewers, provide publicity for paper submission and participation in conferences, collect nominations among technical committee members and recommend individuals for serving in technical positions of CTSoc conferences as TPC chairs, workshop chairs, tutorial chairs, publication chairs, and TPC members. They are responsible for providing conference tracks and session chairs and collect proposals for hosting conferences, as well as for academic and industry conference speakers. So basically, they are providing a number of opportunities for members to serve. There's a page devoted to listing outcomes and opportunities of achieved or provided by technical committees. But just to provide you some examples, in the last years, the technical committees have identified technical positions and named service in technical positions for CTSoc conferences like ICC Las Vegas, ICC Berlin, the Games, Entertainment and Media Conference. They recommended names serving now as associate editors in our publications like the Transactions on Consumer Electronics and Consumer Electronic Magazine. They organized special sessions in journals. They organized workshops and special sessions in conferences. They have been involved in initiatives like the IEEE Digital Privacy Initiative, or they are and are being involved in initiatives like the digital reality and its transformation from the initiative to a technical community. They supported collaboration with other societies like the Signal Processing Society or the Audio Engineering Society. They created special interest groups like the one on the metaverse. And last but not least, they were involved in the organization of several webinars and technical talks. And this is what I'm presenting you today, the technical talks of CTSoc. We build on the success of the series of talks which were organized over the last years in individual technical committees, and we created a brand new series of webinars named the Technical Talks of CTSoc. Basically, every month, 2 technical committees join and organize a talk like the today one, in which they call for volunteers, for speakers among the members willing to give us a talk. And today, there will be 2 speakers selected among the members of the SMC and the CEA technical committees. And I want to thank the officers and the chairs of these 2 technical committees, Himanshu Tafilal and Bernard Fong, for having organized this webinar. If you're interested in contributing as a speaker, please contact the officers of the technical committees in charge of the month event. The next one will be in July. The SEA and the SPC technical committees will be involved in the organization. But as you can see, the schedule for the next month is already here. You have a calendar. We're still just missing the dates that will be arranged with the speakers. So once again, welcome to this first event of the Technical Talks of CTSoc series. If you are interested in these activities, if you're not a member and you want to join, please frame this QR code and you'll be directed to the webpage of the technical activities area. Thanks again, and I leave the floor to the organizer for the introduction of the speakers and the talks. Enjoy the talks.
Okay, so that was the introduction from our Vice President of Technical Committees. So now we will like to start with a talk, So myself, Himanshu Thapliyal, I am the chair of the SMC Technical Committee, and Dr. Bernard Fong is the chair of the CEA. So that in today's talk, actually, we will have one speaker, Dr. Lavanya Rachakonda from that she will talk about the as a representative from the Smart Cities Technical Committee. And Dr. Bernard Fong is going to talk from the Automotive C Applications Technical Committee. So let me start with the first speaker, Dr. Lavanya Rachakonda. I will read her small biography. She is an assistant professor in the Department of Computer Science at the University of North Carolina, Wilmington. She received her PhD and Master of Science in Computer Science Engineering from University of North Texas. And currently she is working on multidisciplinary areas such as machine learning and artificial intelligence in the areas such as smart cities, smart healthcare, transportation, automotives, and the healthcare domain. So with that, I'd like to welcome our first speaker, Dr. Rachakonda, and please help me welcome her. So you can share your slides.
Yeah, okay. Thank you so much for the introduction, Dr. Thaplial. So with that, I'll start my presentation. Okay. I hope you all can see my screen.
Yes, we can see it.
Okay, awesome. Okay, so let's start. The title of today's talk will be Smart Cities and its Components. So just a little bit about me. As Dr. Taprihal has mentioned, I'm an assistant professor in UNCW, Wilmington. That's in North Carolina, USA. And my research topics basically include developing applications and variable systems, non-variable systems, or any automated systems using IoT and IoMT. In the main areas will be smart healthcare, smart agriculture, smart transportation, smart cities, etc. So at a glance, I have worked with quite a good number of students as of now, considering that I have only started in 2021. And I still have many more students lined up for me, to work with me. And I have ongoing publications, and I'm also submitting grants, and I'm also open to collaboration. So if you all find the topic that I'm going to talk interesting today, so please reach out to me through my email, or this is my website. Okay, so with that, let's jump to the talk. So the outline will be first, we'll be talking about smart cities. What actually is smart cities? What is the smartness in the smart city? Where does it come from? And then we'll take it to the definition, next the attributes or the components that involve smart cities and that make the smart cities actually smart. And then we will talk about some specific examples with respect to each of the component. And those examples will be basically from what I have done in the past and my current projects. And then we'll talk about the design of the smart cities a little, and then we'll talk about the challenges that a smart city can face in the future. So first, let's start with the need. For effective management of the limited resources that every city has, it is important that we maintain, the rapport between all the resources. And that is why that is also one of the needs for smart cities. That is to increase the livability, to improve the workability, and also to enhance the sustainability of a particular city. So as we need effective management, we will be talking about how to manage that and also what it means, like when we say managing the three points that are listed here. So when we are talking about smart cities, it's not just the bigger smart city, but there could be smart towns, smart villages, or something or smart counties for that matter. So I have just narrowed it down to smart villages here, but it could be smart counties, smart towns, as I've mentioned. So smart city can be termed this is one of the basic definitions, can be termed that a city which has the capability to connect the physical infrastructure, the IT technology, the social infrastructure, the business infrastructure to increase the total level of intelligence of a particular city. So basically with this that we get the idea that smart cities should be able to communicate or should be having the intelligence to communicate, to data transfer, to satisfy many more requirements for it to be called as a smart city. When you are narrowing it down to smart villages or smart towns, we can just say that a village or a town that uses communication or advanced information and communication technologies for social development can make it a smart village or a smart town. So when we have multiple smart villages or a smart town in a particular area, then we could just consider it as a smart village, or sorry, smart city. With having multiple smart villages, we can just state them as a smart state, and then becomes the entire country, like which can be termed as a smart country. So you get the idea. So it's like we are starting from the basics, starting in the smaller groups, and then we are increasing the reach. So when, like from what I have said earlier, the city needs to be intelligent enough to have any sort of communication or to have any thing to be converted into a smart thing. So for that, IoT basically holds like the backbone. IoT is nothing but Internet of Things. So basically, we will be talking, we will be looking at the architecture of the IoT in the next few slides. But basically, IoT can be defined as network of devices or network of things which can share information with each other and which have unique IP addresses, so that you could either verify if you have the perfect source, or if you can also verify if you want to send the information to a destination. So some of the components can be agriculture automation, building management, energy management, embedded systems, wireless sensor modules, wireless sensor networks. And then we have smart cities, which is also one of the major components of IoT. And then we have healthcare, which can be involved in anywhere. Like we could bring healthcare to agriculture. We could bring healthcare to our everyday things like assisted vehicles or smart transportation. We could bring healthcare to smart infrastructure like smart buildings. We could bring healthcare to smart cities as well. So it is an overlap, but it is a decent overlap. So from this, the basic definition of the smart cities can be termed as regular cities plus the information and communication technologies, that is to be able to communicate or transfer the data from one thing to another thing, and then having smart components plus smart technologies. So everything, like, it can have multiple plus, so it's just not limited to these four. We could have like smart people, because if these people are not smart enough to use the technology that is provided to the people, then there is no point in providing a variable or in providing technology. So there are like multiple attributes or multiple components, but the basic components of what I could think of as basically information technologies and then communication technologies plus smart components and smart technologies. So a city is so other basic definitions, like the definition one is from basically what we have seen in the a couple slides earlier, that is, which is connecting a city that is connecting the physical infrastructure, the information technology infrastructure, the social, the building, the business infrastructures to regulate the entire intelligence of a particular city. The second definition can be formed as a smart sustainable city that uses ICTs in order to improve the quality of life, efficiency of urban operations, competitiveness, while ensuring that everyone that is present, so also the present generations, and the future generations are benefited from the all the programs that the smart city is holding, so that they can expect or they can see growth with respect to economic, social, and environmental aspects. So this basically, the definition 2 covers all the attributes that we have looked here. So agriculture is also an important component of smart city. Buildings is again an important component of smart cities. So everything needs to be smart for a city to be called smart. So that can be your definition 2. So now when we are talking about components or attributes, there are like three different, or the three main components. I'll be talking about many other components which also affect the the bigger idea of smart city, but the three main components will be three I's, that is instrumentation, that is basically all the smart technologies and smart components will be coming under. And then you have the second I, that is intelligence. So like without having a proper let's say automated solution, which is to a previously existing solution, then there is nothing, like there is no novelty, or which is the intelligence needs to be there in order to make the solution much more feasible to anyone who doesn't have to ideally understand the concept of intelligence or the working of the model. So intelligence, and then we have the interconnection that is basically able to transfer information from one component to another, data transfer, data security, data privacy, all that with respect to interconnections. So the three main I's are provided by Internet of Things, as we have already seen in the previous slide. So IoT will make sure that all the three things are combined together, and then it is, or IoT will be a domain that will just allow us to use all the three I's in a way that they are supposed to be used to make a city a smart city. So the architecture of IoT can be something like this. So here I have three different types of things. One is a plot of land to represent the agriculture domain. And then you have the smartwatch to represent any smart devices that are present in the current world. And then you have end sensing devices like sensors or wearable networks, or let's say a mirror in a particular building which is smart and that is contributing towards a smart building or a smart infrastructure domain. So we could have like multiple more domains. I just represented three here, which are also termed as things. So basically this thing or cluster of things are connected together, and all this information is uploaded or sent by using a router or the gateway communication, which is otherwise called as Wi-Fi nowadays. Or we could also use other technologies like Zigbee, Bluetooth, NFC, depending upon the application or depending upon the goal of the problem. And then all the information is transferred to internet for cloud services to store the data, process the data, whatever the application deserves. So what I usually do is I do all my computations on edge. So I process all the information towards the user, and I only use the cloud services to store the information. So in the next slide, when I will be talking about the specific examples, you will be like you can notice the same as well. So in order to design a particular smart city, first thing is setting the vision for smart city venture. So without having a vision or without having an idea of what to do next, there is we cannot reach point 2 unless we complete point 1. So it is like having a vision to make it to make some initiative to make the city smart city is your number 1. Next is identifying the targets. So what are the primary areas that needs, the technologies that we have just discussed? Is it like the agriculture, or is it the people, or is it the building, or is it everything? So identifying the targets will be the second step. Achieving political cohesion, because as we are talking about cities, it involves a lot more attributes than just components or people. It also involves some political attributes, government aspects. So making a collaboration with them or having an understanding of what to do or what can be done or what cannot be done. Next, building the smart city. And most of them like just stop at step 4, which is, you could just, instead of just proposing something or proposing a plan without having a feedback, is considered as an incomplete plan. So the next step will be measuring the smart city's progress. So it's like, is it actually affecting the city's growth, or is there any change with respect to people's social, economic, or emotional growths as well? So measuring smart city progress will be the next crucial step. And finally, ensuring accountability and responsibility will be the step 6. So this is not like, this is not just the top-down approach. It is a connected approach. So if there is any issues with the accountabilities, or if there is any changes that needs to be done, then again, setting visions to change those parameters and then rebuilding the entire plan will be the following step. So basically you'll have main 6 steps, which can be overlapped or which can be connected all together to make a city a smart city. So as I've told earlier, there are certain components that make a city a smart city. The first thing that I think is very important is citizen engagement, or the people. So basically, people play a large, people are important for any city. Every town has people or population. So citizen engagement is crucial to large-scale infrastructure projects. So local citizens need to be aware of and prepared for any changes to be occurring, and they should be well informed of what is coming and why it is affecting the process that they are currently following and how the next process could be beneficial to them. When citizens and municipal governments work together, then the positive communities can be achieved sooner. So as I've mentioned, that is point 3 here. We are basically bringing the citizens and the governments to work together so that we can propose large-scale infrastructure projects which will indirectly or directly impact a city to become a smart city. The second component I think that is important for a city to become a smart city is the infrastructure. So there is infrastructure involves buildings, water management, facility management, trash management, every little thing that let's say a community needs, or all the amenities in a community can be considered as infrastructure. So improving the efficiency and capabilities of government services is key to preparing for and maintaining a sustainable growth. So critical infrastructure services include city-wide facility management, wastewater management, and water distribution as well. So here are some listed, but there could be many more. So all this to improve the complete sustainable growth of this infrastructure, all the methods that they're currently following can also be improved to make it to rather take it in a smart direction. The next component is connectivity. Like if there is no internet, then there is no point of proposing so many variables or so many systems or so many smart systems when they are having a limitation of connecting with one another. So internet has become an essential service. We all know that. We are all living in that particular era, and none of us can work without internet. So it is similar to electricity. So when there is no electricity, then there is no internet, and it's vice versa. So as a result, there is a critical need for information and communication technologies and public Wi-Fi, which because not everyone, let's say, like if we want our solutions to reach to even low income families to high income families, so then we have to propose solutions keeping such backgrounds in our mind as well. So high-speed internet connections allow for economic development and the growing remote work trend. Now with COVID and past COVID, most of the companies and the employees are preferring working from home. So then there is a definite need of promoting, or there is a definite need of improving the communication technologies and Wi-Fi connectivities. So the next component I think is important is public safety. So in terms of technology, many tools can help sense, analyze, and act to potential public safety trends. So like, let's say if there is a threat outside, like a shooting incident, or if there is someone with a weapon that wants to hurt another person or a bunch of people. So there can be many threats that a society in a general can experience. So if we have some sort of technology which can monitor, sense, and analyze to potentially reduce the threats, then that could be great. So for example, smart cameras can detect accidents and call for emergency services, and microphones can detect gunshots, shooter's location, and then relay that information to the closest first responder. So there could be some privacy issues, but first step is to propose a solution. Next is to work in order to make that solution workable for almost anyone. So that again is like basically collaborating with the governments and then making sure that there are like no political aspects of a solution to like stop from the solution being in market or getting published in market. So if there are like situations, if there are like unfortunate situations in the society, then having technology can help reduce such incidents, and that would be great, like for public safety. Next we have is resiliency. So cities need to be resilient to any challenges that may face, particularly considering with critical infrastructure services that citizens rely on. So if there is a sudden change that needs to be done in a particular city, then the city itself should be able to handle that change. So, like, if faced with rising water, inclement weather, or extreme conditions, technologies like renewable energy, smart grid, centralized building automation, communication redundancy, and asset efficiency can help cities avoid critical failures. Like, for example, let's take this scenario that maybe like 3 or 4 years ago, can't remember the exact time, when there was a sudden snow in Texas. So most of the counties in Texas were not prepared for something like that, which is like a definite weather change, extreme condition. And then there were so many reports of people losing their lives because of the sudden cold. And then there were pipes bursting inside the apartments. There were flooding inside the apartments as well. So all this can be controlled if the city itself is resilient, and if the city itself is prepared for any sort of extreme conditions. Like ideally speaking, Texas, or particular counties in Texas, or particular areas in general, may not be expected to receive some extreme conditions, but also with the environmental conditions that we are actually having or facing. So, like for example, considering global warming into consideration, it is good for a city to be prepared for anything that it might face. So healthcare will be my next important component. So as I've mentioned before, a city has different types of backgrounds of people. So it could be poor, rich, middle, lower class incomes. So enabling healthcare across all the backgrounds, which enables access for all and nutrition the social, economic, and environmental factors, can contribute for overall well-being, which can be like the most important goal for our smart cities. So telemedicine opportunities for homebound individuals are an excellent example of how digitalized cities can better serve citizens. There are other examples, as I'm sure you're already aware of, that is smart watches, smart home systems. Like for example, if there is a Parkinson's patient in a particular location, instead of having a third person or a second person to continuously monitor the patient, we could just have a camera that is mounted on the wall, which is connected to the internet, which is again connected to the healthcare provider, to monitor if there is a sudden fall in the person. It also works with the elderly as well. So if the person is falling or is about to have a fall, then we could just trigger a notification to the healthcare provider or a nearest family member to just come and check on the patient. If the patient falls and is unconscious, then the person will not be able to ask for help by himself or herself. So in that situations, our technologies or our solutions which are in the healthcare domain can actually help the people to have a better life or to even save themselves from disasters. So the next component I think it's important is the transportation. So enabling intelligent transportation systems or using traffic management centers is vital for cities' growth, because more the number of population, there is a definite chance of having more traffic. So for example, traffic management centers can monitor and coordinate large networks of sensors to improve traffic congestion. Additionally, with the expected surge in all electric vehicles, cities will need increased charging station availabilities to make charging easy, accessible, and equitable. So, for example, these days Teslas are growing. Like if Tesla's chargers are compatible with Rivian's or any other automated electric vehicles, then it would be better with respect to the space, with respect to the energy, and would also increase the convenience to the users as well. So having such improvements in the transportation area can actually improve the entire overall growth of the city. So not only this will benefit citizens, but will also help reduce carbon emissions, meet CO2 reduction goals, and also reduce harmful pollutants, which also links to global warming that I've mentioned before. So having or keeping environment in the background, like when we are designing a solution to better or improve the city into a smart city, is also a good idea. So data analysis is very important component. Like this is not directly related to smart cities, but this data analysis can help in making any of the solution or in proposing any of the solutions to make a city a smart city. So basically, to access better data management and on understanding the 3 V's, that is volume, velocity, and variety, will enable cities to make better and faster decisions. So instead of having just straight, like, A to B solutions, what if we have higher amounts of data, different types of data, and with the various velocities, that is like mix and match of data with that example. So in that case, then the city will also be able to predict the solution for an uncanny situation. So the cities will also be ready or be prepared for anything that can happen or that can occur. So with actionable data, insights, policymakers and can improve operations, reduce resource consumption, monitor security risk, and also better manage budgets. So now let's dive into specific examples. So as I've mentioned before, all these examples are my research. So either that I have worked in the past when I was doing my PhD, or even and also my current research. So this smart infrastructure, I wanted to bring in this project, that is iMirror. So this is basically a smart mirror to detect stress in the IOMT framework. And this can advance smart cities, as this can be installed in almost all the office buildings. Thereby we could just monitor the thereby you can just monitor all the facial features and also the stress levels of the person. So if you see here, we have like data, automatic data processing, stress rate analysis, and then the user interface is just the mobile application, and all the data is stored in the IOMT cloud. So basically, IOMT is stands for Internet of Medical Things. So when the same concepts of IoT are applied for medical applications, it can be termed as IOMT, or it can also be termed as IOHT, that is Internet of Health Things. So this is one of the examples of smart infrastructure. The next example that I have is for smart transportation. Here the idea is to propose a fully automated system to analyze if a person is stable enough to drive a vehicle. So here we are monitoring the BAC levels of the user. It is called as Batmobile, taken from Batmobile. So this is basically BAC tracking mobile. So this is a smart blood alcohol concentration tracking and mechanism for smart vehicles in healthcare CPS framework. So here we are also using the blockchain technology to provide secure access of data and also secure transfer of data. So the sensors will be embedded inside the steering wheel, and then there is a camera to monitor the facial features of the user. I have only taken an image with the pupil dilation here, but we are also considering various other features like puffiness, forehead frowning, eye redness, eye bags, etc. So here I have used a mobile net based network and an SSD network, and then we have classified the images, and all the processing that is presented here is done or was done on an edge device. So having such vehicles, like, which can eliminate the need of a second or a third person to let the user know or let the driver know that, hey, you're drunk, you cannot drive. And if you drive in this state, then there's a definite possibility of having an accident. So instead of having all these conversations with let's say a police officer, it is much easier and feasible if the car itself lets the user know that he is not in a position to drive, or is not stable enough to drive, thereby to reduce accidents. Next component is, next specific example is with the healthcare aspect. So here we have proposed a pillow that is also called as Sayo pillow, that is smart yoga pillow. So that is basic.
Lavanya, actually, because of we have to have the other speaker also. So can you please summarize in next 5 minutes?
Yeah, sure, I can do that. Sorry about that.
No problem.
So we have SIO Pillow to monitor the sleep and also the stress levels of the user. That can also be a smart component, smart healthcare component. And also we have iLog, that is to monitor whatever the user is eating in order to detect if it's a normal eating or stress eating. And then coming to the smart people, I have proposed this mobile application where all the devices are connected and the user will be able to analyze and understand what the person is going through in order to control his stress levels. Smart agriculture is again important component of smart city, as I've discussed before. So here are some of the examples. So I have ETS and then AgriAid, where like all the topsoil health and the soil health are being monitored. So some of the challenges, these are like very minimal challenges that I could think when we are talking about smart cities, is pollution, otherwise can be termed as the environmental aspects, that is global warming and etc. Next is water crisis, energy crisis, traffic, etc. So all these bullet points will be falling under the major branch, that is environmental crisis. So I think all of these can be huge challenges for smart cities. So in order to, when we are coming to conclusions, I think there is a definite growth in the consumer technologies, and those are the building blocks for smart cities. And there is a definite development for the smart city technologies. There are multiple research activities that are being performed by academia and industry that are happening. And with the collaboration of both, I think there's a definite scope of achieving or reaching the goals to make any city a smart city. So with that, I conclude. So if you have any questions, please let me know. And I'm sorry if I've taken more time.
So I think it was a great talk and very informative. Thank you for such a great talk. So now it is an opportunity for any questions from the audience. Actually, we can just take one or two questions. And if the rest of the questions, you can reach out to the speaker through email. So is there any one or two questions?
Maybe a quick one, Lavanya. So you have talked about the interoperability or interaction in one of the three I's. So
Yeah.
do you see any standards coming up for interoperability or security for under the title of smart cities today?
I'm not sure about the standards, but I think there can be a lot of solutions which can mitigate like the three factors together. But yeah, I'm not sure about the standards.
I'm specifically asking in context of interaction because multiple devices need to interact with each other. So there, how the interoperability is ensured and security is also a concern, same as privacy that you mentioned. So are there
Yeah.
any standards that you see in your research that they are picking up, or it's not yet picked up?
There are some research that picks up the things that you've mentioned actually. So my research, like Back Mobile, there we have made sure that all the information is securely transferred, securely accessed. So thereby, like we have used blockchain for that. So I think there are some research articles which are also contributing towards the same. So I would say yes.
Okay, thanks.
Yeah, sure.
Okay, any other questions from the audience for our speaker? So in the interest of time, let's thank our speaker. Thank you so much, Lavanya. It was a wonderful talk and we're pleased to have you here.
Thank you.
So yeah, thank you. And now we'll move to our next speaker from the automotive CE applications. We have Dr. Bernard Fong. He is also the chair of the technical committee for automotive CE applications. I will have a brief bio for Dr. Fong. He received his BSc degree in electronics from University of Manchester Institute of Science and Technology, and PhD degree in health information systems from University of New South Wales. He is currently with the Providence University and has previously served as a lecturer with University of London, senior lecturer with Auckland University of Technology, associate professor with Hong Kong Polytechnic University, and became a chair professor of Guangdong University of Technology in 2014. He is currently the managing editor of IEEE Smart Cities newsletter and academic editor of PLOS ONE. He has published over 140 articles. And with that, I'd like to welcome our speaker, Dr. Bernard Fong. You can share your screen.
Thank you for the introduction, and let me see if I could get my screen up, because I do apologize, because it seems that it's quite difficult to share things in WebEx. In fact, I was kind of like on and off just
So
now because of
we are seeing your blank screen. If you just try to change the
blank
slide.
screen. Okay, wait. Let me go back to WebEx first, because it seems that my MacBook is not happy with various things like permissions and that kind of things. So sorry. Let me close as many other things as possible first. So I'm hoping that I could go back to my WebEx, because looks wait. Sorry, I'm still struggling with going back to WebEx.
So you
If you are okay, you can share with us.
Okay.
And one of us can share it.
Open system setting. That's what they want me to do.
No, I'm just saying, if you can email me the slides, I can share it for you.
Yeah.
Oh, okay, great. That would be great.
Yeah,
Maybe that would be the quickest thing. Okay, I think I'll click reply from the email, and I won't write anything there. Just to do the fastest thing possible. So I'll just drag my PowerPoints over. Wait, okay. OneDrive. Sorry, I'm trying to open my OneDrive now. And things are just getting so badly organized. Okay, I see it now. Everything is kind of like scattered randomly. Okay, so I'll just reply to that email, and okay, I just click send. So hopefully you can receive my PowerPoints there.
Yes, and then
okay, I see that my MacBook now is still in Safari, so I definitely want to go back to WebEx. Let me try to close as many things as possible. Okay, here it is. So no, it's not. It seems that I'm now only having a small window opened in my WebEx. It doesn't let me go back to my full screen as it used to be a few minutes ago.
Maybe you can try. I don't know. Maybe trying to logging out and logging in again.
Okay. Let me try that. Sorry about that. So I'll close my WebEx, and we'll be right back.
Yeah.
Hello, everyone. So I'm back, and
Okay.
I don't know if I want to try sharing again, because it seems that when I
try it again.
To share just now my PowerPoints, this WebEx seemed to behave very strangely.
Did you email me the slides?
So let me try again. So
no, I think
PowerPoint share. Let me see if it.
Is
it working this time?
No, I think it is showing something, but nothing is coming as visible. So you try to change.
Strange. Okay, at least I can see a stop option. So let me see if I could stop that.
Yeah.
Okay, seems that at least now I can go back to where I was. By the way, did you get my PowerPoints from email?
Yes, I got your slides.
Great. So maybe you can help me share then.
Correct. I will do that for you. Just give me a minute. And whenever
Great,
you want,
thanks for that.
whenever you want me to change the slide, just let me know actually. Okay.
Great, thanks.
So you can see the slides.
Yes, yes.
Okay. So
That's
go
great.
ahead. So go ahead, and then whenever you want me to change it, I will
Great,
change it.
thanks. So maybe you can help me go straight to number 3, since you have already helped introducing me to the audience. So I guess we could go straight to slide number 3, please.
Just give me a minute. Actually, there is something happen. Okay, slide number 3.
Yes, please. Thank you.
Okay, I'm just trying to minimize this. So many other pop-ups. Okay, so this is slide number 1, 2, and 3. You're fine?
Yes, great. Thanks. So let me start. And now I see that we are actually approaching the hour. Oh, by the way, greetings from New Zealand. So I'm now back to my New Zealand home for summer holidays. So it's getting towards 9 a.m. over here. So I can see that actually I don't have a lot of time, and I'll try to go through this more quickly. But the good news is because Lavanya actually gave a very good talk, and I do see that my particular topic is actually an extension of what she has been discussing. So that's one very good thing, and actually she saves me quite a bit of work. So I will go straight into this smart mobility idea, and more specifically, I would like to cover a little more on the CT and CE application side. So micromobility basically is the idea of using some very small vehicles primarily designed to concentrate people for commuting between their homes and public transport hubs. So in many suburban areas, this would be a very useful kind of transportation mode. And very importantly, safety first and also efficiency. So having talked about micromobility for commuters, actually there's another application that is quite important in the context of CT, because it does also serve as a mobility assistance for elderly who may have mobility problems. So it does help with transporting elderly as well. So that obviously can integrate with smart home to do various things like assistive care and health monitoring, that kind of things. Please move to slide number 4, please, because I need to go reasonably fast. So please help me go to the next slide.
We're in the slide
Okay,
number
so
4. Yeah.
Great, thanks. So more about CE in micromobility. So first of all, safety, as I touched on a little earlier, a short while ago, and this, of course, would be very important in terms of doing something like traffic analysis and also forecasting, like route planning. And of course, one other important thing is to deal with road maintenance. So there are certain areas like people want to avoid, and also there could be some hazards. For example, there could be things like some large potholes in the road, or something that has been fallen out of some other vehicle or something like that, that could cause potential hazard. And these are things that can be avoided. But then, of course, in CE, there's one other thing that do quite the opposite. So just now, when I talked about safety, we could want to possibly avoid certain areas. But in the case of trying to generate revenue, actually, we could do the opposite by attracting certain people, like most of us probably see things like on various social platform, social networking platforms like Facebook. We see a lot of advertisement, and that is exactly something that we could do in micromobility as well. So try and generate some revenue with advertisement, try and pull potential customers to certain areas. So that's one thing that micromobility can do as well. And of course, in terms of consumer technologies, we could do things like something about the health of both the patient, for example, monitoring like chronic diseases, COPD in particular. As we all know, especially in metropolitan areas, the air quality can be quite bad. So for COPD sufferers, if we could have things like air quality improvements, at least in the small vehicle, that could probably help those patients. And also, just like what I said a short while ago, it could also be linked to smart home applications as well. And one other thing, of course, is by moving more efficiently, hopefully we can reduce emission, and that, of course, would do two things, like first of all, save time, and secondly, to help reduce pollution. So that, of course, we are trying to do both of these, so saving travel time and also energy consumption. Please move to the next. I guess I have to go really fast now because we are okay. So this one is actually an example from Tokyo, where I went to a motor show quite recently, and they have this very smart route planning system. So this particular map, very quickly in a few words, it shows the optimal path. It does a lot more than Google Maps. So you might think I'm talking about Google Maps. No, I'm not, because it does things in a much smarter way. And apart from helping with smart mobility management, it does also help with fleet management, so that things like logistics, supplies, and also emergency response, they could do it more efficiently with this kind of planning. Next, please. Next slide, please. Okay, so the basis of all these basically rely on Internet of Vehicles. So let me very quickly summarize due to time constraint. We need a very, actually we need two very reliable and efficient communication networks, i.e. a vehicle to infrastructure, that is V2I, and also another one is V2V, vehicle to vehicle. So in terms of the challenges to make these networks reliable, we have to ensure that vehicles are well covered, even when they sometimes move outside cellular coverage areas. So there are various ways of doing that, but due to time constraint, I don't think I will go into the technical details there. But a very quick summary is that we need to have two of these separate networks to run together in order to support these micromobility and related CTSoc applications. Next slide, please. Thank you. So going back to the fundamentals, one very important thing is security, because well, I'm not going into information security because we all know about the basics, but one very important thing is hazards. Think about what happens if a vehicle is attacked so that it gets out of control. This could be a very dangerous situation and something that we must avoid. So quick summary is that in many, well, in fact, virtually all CTSoc applications, security is very important, and micromobility is no exception. Next slide, please. Looks like I'm already overrun, so I have to be very quick. So vehicle network optimization. Basically, security, one thing, and of course, we also want to make sure that our vehicles are connected so that in the event of an emergency, the consumers can cry for help. One other thing is to make sure that the vehicle is healthy, in that there's nothing wrong and it's not going to break down somewhere along the road. So in order to do that, diagnostics is extremely important, and that's one thing that consumer technology kicks in, because this part, the vehicle, if it's being linked and also self-monitored for anything that is going to go wrong before it does, it can link up to the service center, and various things, of course, can be prearranged so that the downtime can be minimized. Next slide, please. Okay, so this one is a very quick run of the management network. So it's self-conditioned in that it uses AI to self-monitor and also to do self-adjustments. And due to time constraint, I think I won't go through the details, but hopefully we can find some research collaboration opportunities to work on these things. So I think we'll proceed to the next slide, please. So business intelligence is perhaps the main topic that I would like to talk a little more, because I see this as business opportunities related to CT and CE technologies. So like the earlier part about micromobility, actually I have hopefully I have covered the communications and also the smart mobility, the smart transportation technical side, hopefully in brief at least. But in terms of business intelligence, this is where we could integrate into various other application areas to hopefully yield some profits. So linkage to shopping mall as an example, we could potentially work with various marketing agencies and also retailers chains to offer our consumers certain incentives. So this business intelligence idea is set to integrate into micromobility vehicles, like for instance, for parking, to provide the consumer with a good parking spot, and of course that is close to the shopping area where the business partners are. So this kind of idea actually benefits both the consumer and also businesses. And of course we can do that to spread traffic. So ease congestion, generate revenue, and also for the benefit of consumers. Next, please. Next slide, please. So this one actually shows us the implementation strategy. So very quickly, it looks at the relative location of the consumer to the shopping mall, for example, and to balance the traffic flow, and also to help generate revenue. So I think that's where I would like to conclude. Next slide, please. So future directions in terms of research, first of all, consumer healthcare technology for disease management that could be integrated, and also obviously smart home integration, as I discussed a little earlier. So infotainment system, also another important automotive CE area to explore. So I think that's all I have, given the time constraint. By the way, sorry for being overrun and all the problems before I actually got to start, and really appreciate your help to set this up and also help me with the slides as well. So thank you, and wonder whether there's any questions from the audience.
Okay, so thank you, Dr. Bernard. So in this case, do you have any questions from the audience? Any questions? Okay. I have one question for you, Dr. Bernard Fong, actually. How do you see the like this smart transportation, like internet connectivity, playing the role? Let's say nowadays you want to have this autonomous connected vehicles, right?
Yes.
Now,
yes.
how do you see, let's say if you're driving in the rural areas where there is no good internet connectivity, what do you think will happen in those areas?
Yes, I think the most important development area would be vehicle-to-vehicle communication, like setting up a relay network, so that hopefully nearby vehicles can help relay important messages and eventually reach a nearby base station. So I believe that would be the way to go forward.
Great. Any other questions from the audience? Okay, so if there is no further audience for the question from the audience, let's thank our speaker. And it is thank you everyone for being with us today. And with that, I would like to conclude our first webinar of this CTSoc Technical Committee. And thank you and see you all. Bye.
Great, thank you and have a good day. Thanks.